We have a fair amount to discuss about northern pike and smallmouth bass as well. So we do want to get input from everybody if possible, but for the first part of the agenda, it's going to be just the input group, and then there'll be an opportunity near the end of the meeting to hear from the folks in the gallery as well. So, but we don't want to be here too late. We know we got some bad weather coming in, and some folks have driven quite a ways to get here. So I'd appreciate it if you could basically follow our agenda, and again, let's keep the input initially with the input group here at the table, and then again, we'll open it up later on. I do want to introduce Brad Parsons. Brad is the Region 3 Fisheries Manager, and because a lot of the challenges on Mille have increased the complexity, and we've got to do a more detailed job of communicating. We brought Brad on as project manager to help us manage the workload with that. So, and because we have a complex meeting tonight, we're using this new technology. You just got your little input device. We're going to use that in several spots during the meeting. We've used this internally for some of our meetings, and it works pretty slick. Tom will run us through just kind of a quick trial on that so you can see how that works. But it allows everybody to submit their opinion on critical parts of the meeting anonymously, so you don't have to worry about, offending anybody else or whatever. So they work pretty nice. We've had good success with them internally with meetings. So, and I also, because we do have a lot to cover and we have a complex meeting, I want to introduce Tom Futek. Tom is at the University of Minnesota. He's a well-experienced facilitator. We've used Tom before, and he does a great job at running meetings. So with that, I'm going to go ahead and hand it over to Tom, and we'll get to this.
Great.
Thanks.
Thank you very much, Scott. Thank you, first of all, for the invitation to join me today. As Scott had mentioned, the reason I was invited really are two reasons. Number one, this is important information. It's important for you, it's important for people from Indiana, from around the lakes. And so we have a lot of information to get through. I want to give them the greatest opportunity to be able to listen and participate, so they don't have to worry about simply the simple movement from one agenda to another. So please let me just handle that part so we can move in an efficient way and get through a complex agenda in a very efficient way. Secondly, though, and not contrary to the first, it is incredibly important, as you know, for everybody's voice to be heard. We are here not just to listen, but to be able to express our views. They are important. You wouldn't be here on a Thursday night if they weren't. So allow me to be able to make sure that we get as much of a representation of voices as possible. And by that, I just simply mean when we have an opportunity for input, first of all, from the input group here.
We had to change our management strategy in the lake to accommodate the treaty fishery. And at the time, the best available data indicated that 24% of the biomass of all walleye over 14 inches could be safely harvested from the system. But in retrospect, we think this was probably too high because this assumption, this 24% assumption, didn't take into account the fact that both fisheries were very size selective. And the other thing that it didn't take into account was it was under the assumption that conditions were going to remain stable, that it was going to be productivity, the fish community, and water clarity, all of those things were going to be what they were in the past, which was we were basing that 24% on data that was collected prior to 1998. And so we now know that that's not the case. The system has changed. And so in retrospect, 24% was likely too high. And so now to get into some of those actual changes that have been occurring in the lake. And this graph is the northern pike catch in our inshore gill nets, and it's been steadily increasing since the mid-90s. And in fact, last year it was the highest catch ever. And actually, young of the year northern pike were also at the highest catch ever, which indicates that this trend is likely to continue. And one of the hypotheses we have for why northern pike are increasing in the lake is again related to that change in water clarity and likely because there's more vegetation in deeper areas and in more parts of the lake. And that favors northern pike, who are more of an ambush type predator. They're a site predator, and they just prefer habitat that has vegetation in it. And so another predator in the system that's been changing, and again since the late 90s, is smallmouth bass. And we're not really sure about the mechanism why smallmouth are increasing, but we think it's due to the fact that growing seasons are tending to be longer. And smallmouth bass are often limited when the young of the year can't reach a reasonable size prior to their first winter. And if they can't reach that size, they have poor overwinter survival, and so they have weak year classes. And so as we've had longer growing seasons and growing seasons that extend longer into the fall, this may be favoring smallmouth bass. And another potential contributor to the increase in smallmouth bass could be the protected our regulations that we've had. But we think this is unlikely to be the only reason for the change in smallmouth bass, because this type of trend in smallmouth bass abundance is occurring in other lakes in Minnesota and also other lakes in Ontario and Wisconsin, other places where growing seasons are getting longer. So kind of to bring it back again to water clarity and how this might be affecting juvenile walleye, it's like this is that relative to survival index, and then we have water clarity. We can see that when water clarity is increased, there's been lower survival of juvenile walleye. We think that's probably related to either a change in juvenile walleye behavior, so the shallows are getting clearer, and this is making them move offshore sooner, or it could be the fact that water's getting clearer, there's more vegetation out there, so there's more predators such as northern pike, or it could also be related to the fact that water's getting clearer, the site predators are more effective, and so we're not quite sure what the mechanism is, but we think this suggests that water clarity is playing some role in it. And so switching now to invasive species and what they might be doing up to the lake. This is zebra mussel density over time, and zebra mussels are they're filter feeders. They filter plankton out of the water, and that can lead to changes in water clarity, which again can change the aquatic vegetation in the system, promoting deeper plant growth, more dense plants growth, and also maybe that could be confounded then by making denser beds of Eurasian water milfoil in the lake. But again, zebra mussels were first detected in the mid-2000s, and they kind of bounced, they were increasing during this time, but they really took off around 2011. And this actually is kind of when since 2011, we've had some of the clearest water years ever in the time series. And so zebra mussels could be affecting water clarity, which then in turn could be affecting the plant community and habitat, and then leading on through affecting northern pike and juvenile walleye behavior and all kinds of things. And the other invasive species that that's in the system that could be having some changes is spiny water flea. And their numbers have been bouncing around over time. They were first detected in 2009, but they definitely show no signs that they're going to go away. And what spiny water fleas are is they're a predaceous zooplankton, so they feed on the native zooplankton. And they could be, so between zebra mussels, which are filtering the water and competing with larger Daphnia and larger zooplankton, which also filter the water. And then spiny water fleas that are preying directly on zooplankton in the system, they could be causing changes in the zooplankton community that then work their way up through the food chain. And the reason this is a problem is that small fish, pretty much all young in the year fish feed on zooplankton at some point, including walleye. And so this could be having an effect on juvenile walleye. And there have been some changes going on in the system, and it's like since about 2011 or so, there's been a dramatic drop in the number of small cladoceran in the lake in our zooplankton samples. So that's another thing that could be causing a change in the lake. And the last one I'm going to hit on is there's changes in the forage going on in the system. And one of the big things is that there's been a change in tulipy numbers over time. And this is consistent with a statewide decline in tulipy ones, across the state. And this is likely due to warmer summers, because it's like tulipy require cold water and they require clear water. And as I mentioned, clear water definitely isn't the problem. The lake's very clear now. And so it's likely due to the fact that we're having some warmer summers. And everybody knows they experience summer kills during warm summers. And so, but the reason that this is really a critical thing is that tulipy are a very important forage species for walleye, especially big walleye. They're very high in calories, and so they're a better. The walleye gets more bang for their buck if they eat a tulipy compared to a perch because they're higher in calories. And so to kind of wrap up all these changes and changes that are occurring in the system, and they're all interacting with one another, is that there's the predators out there that can prey on walleye, especially juvenile walleye. They're increasing in numbers. There's been a decline in some walleye prey, particularly tulipy. There's water clarity is increasing, and this might be giving site-feeding predators a competitive edge. And it's like there's the interactions of zebra mussels, spiny water fleas, milfoil, and all that are likely causing some yet to be defined changes in the system, but they're probably changes that we won't like. And there's also changes in the climate are favoring some species over others, particularly smallmouth bass. And so it's like all of these things are likely interacting to somehow influence the survival of juvenile walleye. So to kind of get back to what we're doing and how we're trying to deal with all of these changes, again, we're developing this 5-point action plan, and within that plan, we're looking at regulations for smallmouth bass and predators that hopefully would reduce predation on walleye, and we're going to be talking about some of those later on. We're also having regulations for walleyes. We're trying to have them protect younger walleye. And we're also continuing to we have the predator diet study going on, so we're looking at trying to figure out which predators are eating what fish, and if certain predators are consuming juvenile walleye at a rate that could be causing a problem. We're also bringing in, like I said, with the Blue Ribbon panel, and we're also bringing on contracting with outside experts to make sure that we're doing our tagging studies correctly in the best way possible and getting the most out of those studies that we can. And then again, the Blue Ribbon panel, we're bringing in some of the best experts on walleye and lake system dynamics that we can to review what we're doing and hopefully help us improve the management of the lake. And then we're also looking at new ways to engage the public in the process. And as far as like invasive species, we're open to any feasible methods that might be out there to control them or manage them. And we're also supporting the efforts of Explore Minnesota to kind of promote tourism in the area and maybe expand and promote more than just walleye fishing into the bass and northern and things like that, and just to keep a diverse local economy. And I think, so just to kind of wrap it up, like I said at the start, really our number one goal too is to try to figure out the best way to improve the walleye fishery and how we can do that as rapidly as we can. But it's going to take some time because you're probably aware there's some gaps in recruitment. I mean, we really haven't had a strong year class since 2008. And that's why it's like our management actions have to do what they can to preserve that year class. And then we also are involving the national experts, and we're continuing to do the studies to try to figure out what exactly is leading to this decline in juvenile survival. And then it's like we're following the 2000 year class very closely, so we're trying to figure out. It looked really good last fall, and we're hopeful, and so we're really monitoring that closely, and like with the diet study and stuff, and the sampling this winter, to figure out if that fails to persist, maybe we can pinpoint when it's happening. And then, with that, again, the website, if you want to go back and revisit any of these slides, it has most of them on there. And with that, take any questions or...
Any questions from the input group? Directly to Melissa.
I've got one.
Yes.
A couple times you've glossed over with as little impact to the community as possible. I mean, there were more words in front of it than that, but you're kind of using the 8 box of crayons, not the 64 box of crayons. What are you saying? What do you mean? What does that mean that this is not going to, that you're looking to have a small impact on the community?
It's already been.
Well,
We're gonna talk a little
yeah,
bit about
yeah,
that.
that's kind
Wanna
of
get
the
into
focus of the
Tom's?
rest of the meeting.
Tom's
Oh, I'm sorry.
presentation?
Yeah.
It's just something she presented.
Yeah.
Yeah, well, I mean, we
Yeah.
wanna, we feel like we wanna do whatever we can to avoid, for example, catch
To
release on
release.
walleye, right?
Yeah,
So,
To avoid catching release?
yeah.
yeah.
Don't catch release now?
So, I mean, to not allow any, we want to try to provide some harvest of walleye somehow if we can. At the same time, facing the fact that there's declining spawner abundance because these young fish aren't surviving. So, but again, we're kind of jumping ahead because Tom's going to actually get into kind of the meat of that challenge.
Okay. Yes, sir.
I have a question kind of related to some of the science here. I've noticed in some other studies that have been done on walleye survival that there's some correlation maybe between warm springs and cold springs, warm summers and cold summers on the survival rate of young walleye. I'm wondering if there's some data that you folks have gathered on that or tried to coordinate with the survival rates on these fish from year to year. Matt Ward and Doug Schultz have done that up on Leech Lake, and it seemed to be pretty interesting information and fairly relevant to what was going on. They made a direct correlation between survival rates of young of the year walleye and water temperature. And I'm wondering if that's been done here or not, or if that's something that you would want to look at.
Okay.
Greg,
Doug had a graph from the multi-lake analysis that I did, so.
go ahead.
Well, Greg, they had really rich information on leach because they estimated hatch rates with the OTC marking, so that gave them a leg up basically on everybody. But if you recall from Doug's presentation where you had that graph with stock recruitment relationships with all the large lakes, Mille is in there as well. So we do know that in all the large lakes, I did the analysis, I went into the literature and I used the spring relationships, and they were there, but a much stronger relationship was an index of total warmth for the entire year. It totally swamped the spring signal completely on almost all of our lakes. That signal's a lot stronger up in the Arrowhead than it is down here. Mille is, if you looked at, you probably didn't notice the Mille graph in that one because it was a busy slide that he put up. But the Mille one's a lot noisier. I mean, there is a relationship there, but it's just a lot noisier.
Yes, sir.
With all this clear water and everything that we're on talking about, seem to miss gill netting during the spawn and the non-biological management of this lake. As you showed on your trends, things started collapsing in the mid-1900s. As you said, trying to push it to mid, but there's a correlation between gill netting on the spawning walleyes, and everything has fallen down as there's been more nets and more gill netting, and that's, I think, where the problem is, and we really want to dance around that. This clear water, I mean, it's so obvious what the problem is. Why do you dance around that and you didn't have that on there as a possibility?
Well, young of the year, age 0 walleye production, or our assessments of age 0 walleyes
Okay,
in the
but-
fall are still at or near levels that are higher than they were in the past.
Where are they going to? know, you've got so many large
That's
fish
why
out
we're doing
there.
the predator diet study
Yeah,
to see
and
if
you've been doing that for quite some time now, and I've never seen any,
year.
Well,
any kind of results.
more intensively for a year, round the clock. Keith Reeves did a lot of work in the mid-2000s also, and we looked at diet throughout the season as well. And yeah, walleye eat their own, pike eat walleye,
Yeah.
some
Well, I
bass eat
think-
walleye.
Okay, go ahead. But I think that if you have a walleye lake and you try to make it a trophy northern lake, a trophy smallmouth lake, you know, a trophy muskie lake, and a trophy walleye lake, 4 trophies in a lake that's crazy. Nobody else does that. You know, you've got regulations, so you've produced all these huge fish, one giant eating machine, and you're wondering where the small fish are going, where the perch are going. I mean,
The one thing that seems to, you know, we've been talking about this for a lot of years.
yes, we have, and doing nothing about it.
And one of the key components of the way the growth mechanisms work in the dynamics work as the fish get older, is the younger they are, the more they eat per pound.
Mhm.
The key consumption on fish by the young fish, or by fish, is way higher at those younger sizes than probably the 2, 3, 4 year range than when they get older. So we've actually gone down in total biomass of fish such that total consumption in the lake has actually gone down. And the bigger fish, matter of fact, you know, bigger pike, for instance, eat, and have eaten over the course of this last year, hardly any walleye. On the other hand, smaller ones ate quite a bit in the fall. You know, so there's a lot of stuff that's not, it's not super clear and super obvious that when you start looking at all the information, that the giant eating machine has changed, or is the main mechanism behind the changes. If, let's say that the population stayed the same, and we kept the same number of those walleyes where they were, now all of a sudden, due to water clarity, we have these young fish that are moving offshore a little bit sooner than usual. Now they're in the same mix as those other fish. Even though the population stayed the same, they may be getting eaten more just because they're in the same proximity. So all of a sudden, it becomes, we certainly don't want to push spawning stock and big fish down so far that we become limited from that perspective. And that's one of the things where we are right now, is that we don't want to push it down any further than it is. Let me put it this way, Bill. Last winter, everybody knows last winter, the fish were jumping on the ice. Right? Population of those big fish hasn't changed hardly at all. Are they jumping on the ice this winter? The catch rates are about 1/20th. And that's all due to forage.
Right. We
So
know that.
it's not simply a giant eating machine. And it's certainly something that we're trying to figure out.